My name is Muhammad Bakit Izzuddin Rahmat. My matrix numbers is CE200150. Today I would like to present about our project multivariable calculus. So the first question for the AI1, the problem that I solved is using MATLAB. So the first question is solve the triple integral. So the answer for the question number 1A is we gain is 1.6917 or 203 over 120. So for the question number AI2, the answer is, and this is the coding to find the answer, and the answer is 25.3333 or 76.3 for my answer in handwriting or manual calculation. So for the calculus 1B, this is the coding to solve the question, and my answer that we gain from the coding is 6.3961E plus 03, or the specific answer is 6396.102. So the question number 1CI1, the answer is and this is the coding for solve the question. So the answer is 3.8758. And the last question here, I have a problem with my MATLAB in this laptop because I not add on Explorer. So this is the coding that I use, and then I solve it using my PC, and the answer that I get from the PC is, here is the answer for my PC, from my PC, and the answer for the area is 0.4142 unit per square. So that's all from me for the question number 1. Thank you.
Hi and Assalamualaikum. My name is Muhammad Amirul Aiman bin Rofli. My matric number CE200149. So I'm from section C and group number 3. So I use the app Maple to approve my manual calculation. So firstly, the question 2A, find the first partial derivative of this A1. So we put this equation into this Maple and then we differentiate it. We type diff x, so we get the answer diff y dz. So in my manual calculation is same like this Maple. Okay, for this 2A2, same like question 2A1. So we type this equation to this Maple and then we differentiate it dx, dy, dz and get this answer. So this answer is same like my manual calculation, so the answer is correct. Okay, for the question 2B, solve dz per du and dz per dv by applying chain rule. So this from this equation you have given z, x and y. So we type this 3 input in this Maple and then we want to differentiate y, so dz and du and dz per dv. So we type dz per du, dz per dv and then get the answer. So from my manual calculation, I got, so for dz per du is same like this Maple, and for the dz per dv also same like Maple. Okay, for the question 2C, show that the function z is given certified Laplace equation differentiate 2 times equal to 0. So we input the equation z into this Maple and then what we want is differentiate 2 times. So these are for the code for the to find the differentiate. So when we got dz per dx and dz per dy and get this answer. So the question want to a plus b equal to 0. So from my maple is equal to 0. So from my manual calculation is same like this maple, and I got also equal to 0. So the answer is correct. Okay, for the question 4D, the question want to find implicit defined as a function of x and y. So we input this equation to this maple and must be equal to 0. So what we must do first is we want to find fx and fz, because in my manual calculation and this math formula is use dz per dx equal to negative fx per fz. So we input fx equal to d per dx, fz equal to d per dz, and then get this answer. So we put into this formula and get this is for the correct answer. So from my manual calculation is also same like fx, same, and for the fz is same, and the last dz per dx equal to this is also same like this maple. Okay, for the question di2 also same like di1, we input this equation and must be equal to 0 into this maple, and then we use this formula negative fx per negative fz, and then we find fx and fz. So fx equal to d per dx and fz equal to d per dz, and differentiate it, we get this fx and this fz, and then we input into this formula and then get the final answer is like this. So from my manual calculation also same like this maple, fx equal to this and fz equal to also same like this. So the final answer is also same like my manual calculation to maple, also same. The answer is correct. Thank you.
Good morning, doctor. My name is Yongkit Somkiat, matrix number DE 2026. So for my parts, I want to present for question number 3. So here I'm using the program by using the application of MATLAB. So let's go next to the question 3B. The question asks us to find the work done by force field, and the equation is given by 3x squared plus with y square. So I separate it and then I save it in F1 and also F2. So for F1, I save it in phase 1 to do the integration of F1 by with respect to the x, and then for phase 2 we need to integrate the F2 with respect to y. After that, the work done, so I save it in work done. Actually you can put any variable that you want, so too easy for me, I put as work done is equal to phase 1 plus phase 2, and then I set the limits of the integration from negative pi to 0, and then y minimum which is 0 to 0. So after we integrate, we get this equation. So I save it in work 1, and then after the integration, the second integration, we get this one, and then I save it in work 2. After that, to after integrate, we need to minus this is because of the integration. So I save it in W. So the work done will shows the result. So for the last question, for question 3C, the question asks us to find the area of the first octant of the portion of the cone. So I set these variables as function of SYMS because to represent the mathematical objects, and then after I get the equation for square root 2 x cube, and then I save it in f variable, and then I want to integrate it, the variable of f, for the limit from 0 until 9, And then for the second equation, which is this one, I save it in the g variable, and then I integrate it from 0 until pi over 2, and then the last methods, which is times them together to get the final answer. That's all for me. Thank you.
Hi, my name is Irina Maril, and my metric number is CE200108, and I am from Group 3, Section 6 for Multivariable Calculus, and I shall be presenting for question number 4. The software that I'll be using in solving this problem is called Maple software, where it is a mathematical programming software which we can solve any mathematical equation, and it is consists of symbolic and numeric computing environment. So for the first problem that we'll be solving is question 4b, where we will need to find the divergence of xyz, and to use Gauss theorem to evaluate the flux of the vector field across the surface. So by using the Maple software, so the first function that I'll be using is the restart function, where we'll clear the previous data so that it will not interfere with the data that we'll be using now. And the next function that I have used is with student vector calculus, which is a vector calculus package where we will be using one of its command and or function, which is divergence, also get coordinates. And the next function that we'll be using is with plots, where we want to command the program to appear the 3D drawing for the calculations. So in the first step in solving the problem, after we have set the package and restart the restart command, so we will then set the coordinate by converting the equation into vector field, which is ijk. So based from the question that was given was 1y plus 1xy plus 1z. So the dot between the 1 and y is basically the multiplication. So as you can see, the blue writing at the for our output is to ensure that the output the input that we have insert is correct. So after setting the variables after converting them into the vector field, so we shall now plot our value to produce a 3D drawing. So we will be using the command for field plot 3D, where our variable f comma, so basically x, y, z is we will put the value that we want to plot. So I have used 0 until 4 for x, and negative 4 until 4 for y, and 0 until 4. So the 3D drawing that was produced is shows the direction of the flux. As you can see here, I can use the mouse and rotate around the 3D drawing. Okay, so the next step is to find the divergence, where we simply use the command divergence in a bracket of f, which means f is our variable that we have set earlier, and we shall get 1 plus 1x as our answer for divergence. And finally, for the solution for the Gauss theorem, where we use the triple integral, where we are set to 2 pi, 2 and 4. That's all for question 4b. So we'll move on to question 4c, where we again will use the command of restart with student vector calculus and with plot. And next is to plot the 3D drawing, where we will use the command of plot 3D, and the equation that I have got for our coordinate is 1 minus x minus y, where I have plot that x is 1 until 1 and y equals to 0, negative 1 until 1. And once I click enter, and this is the 3D drawing that I have gotten. the next step is to set our coordinate to Cartesian, where I have used the same function set coordinate Cartesian x, y, z, and we will set our variable f into vector field which is ijk, and the equation that was given in the question was negative 3 over 2 y in the power of 2 negative 2x times y and yz. So once we press enter, the output will display our equation to make sure that it is right. And next is to plot the 3D drawing in order to see the movement of the flux. So I have used the function of field plot 3D f, which is our variable earlier, x equal to 0 until 1, y 0 until 1, and z 0 until 1. So as you can see here, that this is the 3D drawing that we have produced, where you can see the movement of the flux. And we shall then move on to our calculation, where we have used the function of curl f, our variable. So where once we click on enter, then the answer will be 1z plus 0 y plus 1 times y, which is the exact answer that I got in my manual calculation. And now we shall use the value of z, where we use the value for 1 minus x minus y. After declaring the value of z, we will then differentiate the value of z in the respect of x, which the function we have it is written as z underscore x, and we have gotten negative 1. And for z underscore y, which is differentiating z with the respect of to the respect of y, we also got negative. So you can see here the n is basically our unit normal vector for x, y, z. So we use it to declare into vector field by using the value that we have gotten from above. And next, I have used y plus z as my own variable. So, and I have used the function of dot product for curl and the unit normal vector, where I have gotten f equals to 1 negative x. And hence, by using Stokes' theorem, I have used double integral for 0 until 1 and 0 1 minus x, y, then to integrate y plus z in the respect to dy dx. So I have gotten the. That's all from me. Thank you.